Anybody use one of these?
What kind of noise does it make?
Huh?
What kind of noise does it make?
Yeah. Hey, anybody here ever seen an oscillator? They're a great machine. I use them. Here's a little, there's a Adam Federal Equipment here has a bunch of small little oscillators over here on the floor. It's a great little machine. Peter just said, what noise does it make? Because that's the giveaway for an oscillator. An oscillator is nothing more than a device that oscillates over the top of a screen. And usually you can hear an oscillator about 200 yards away because you hear, and that's literally the hexagonal bars here pushing against the screen to push the product through the screen. I don't know where the metal's going with it, but
Why don't they call it an oscillating mill?
why? Because it actually, oscillation means it's going back and forth.
No, I'm saying rather than calling it a granulator.
Oh, yeah, that's a wonderful question. When I worked for Stokes, I had that argument all the time. This doesn't granulate. You're exactly right. But Stokes called it that. So everybody's kind of stuck with that terminology. But I'll pass this around, just pass it back. Look at the surface, and you can feel where the metal is actually, and really, the machine's being used wrong. If the machine were used right, what you do is you stretch the screen and then back it off, and it creates its own gap. And there should be no reason for that metal-to-metal sound if they're set up correctly. Ultimately, what this picture is of the punch heads on a tablet press. Can you see real close? If you look close, can you see little pits on the surface of those punches right here? Can you see that in the book? Those pits, pardon me, where do pits come from on tooling? That comes from the granulation getting between the surface of the punch and the pressure roll. Literally, the powder is getting pressed into the steel, creates metal fatigue. The higher the percentage of fines, the more likely that's going to happen. Something like this is very gentle. It doesn't produce a lot of fines. It's a great way to make a product. So the thing we're passing around here, you can see the hexagonal bars and you can see the wear. The next technology is a Fitts mill, one of the most common types of mills used in pharmaceutical manufacturing today. It can be used with many different types of blades. It has a 120-degree discharge to get the product out, and that's good and it's bad. It gets the product quick, but if I choke feed this at all, the product builds up all the way up into the center of the machine and doesn't discharge well, and it can create problems. It can create compaction. So I have to be very, very careful about feed rates with a Fitts mill. Very consistent. The more consistent I am, the better product I'm going to get off the mill. There are different types of blades or apparatuses to control your particle size on this technology. A couple of quick notes. Number one, so with some products, your operation procedure is going to say blunt edge forward. Blunt edge forward means that you're pulverizing the powders. That means that your powders are not super friable, because if I had a really friable product and I hit it hard, it would blow it apart and create a lot of fines. So if I have a super friable product, I really want to use a knife edge to cut it and give me control particle size, not blow the particles apart. So that's what that picture is showing me. If I have a product that's a little bit more forgiving, I can use it there, but otherwise I have to use a knife edge. And a lot of times, probably a good percentage of the time, we're using knife forward. The problem with knives is they wear out. If you only have one mill, as those knife blades wear, they get rounded, and they become more like a blunt edge than a cutting edge. And so they have to be replaced